for joining me here on this panel. Now, first things first, let's first talk about infrastructure. Stéphane Louillat, c'est vous.
C'est moi.
Vous êtes chef de service électricité renouvelable et réseaux à l'agence gouvernementale ADEME. Et l'ADEME vient de sélectionner les lauréats d'un appel à manifestation d'intérêt qui vise à préparer l'infrastructure future de l'éolien flottant. Oui,
du coup, je vais vous parler en français. Je vous prie de m'excuser,
oui.
Je devrais vous quitter impérativement à 12h30. Merci. Du coup, bonjour à toutes, bonjour à tous. Merci du coup de nous confier la parole ce matin à l'occasion de cette table ronde. Du coup, avant de venir sur le sujet du financement des ports, je voudrais juste rappeler que l'État français soutient depuis plus de 10 ans maintenant les acteurs industriels autour du développement des énergies marines renouvelables. On a publié en 2020 un rapport qui faisait l'état des lieux de l'ensemble des projets qui ont été accompagnés par l'État. Et sur le sujet des énergies marines renouvelables, et plus particulièrement de l'éolien offshore flottant, c'est plus de 30 projets qui ont été accompagnés pour à peu près 500 millions d'euros de financement pour l'ensemble des projets. Depuis 2020, un nouveau dispositif d'accompagnement a émergé qui s'appelle le programme France 2030, qui vise à accompagner la relance et le développement industriel en France autour d'un certain nombre de sujets, notamment autour du développement des énergies renouvelables. Et ce programme France 2030 se traduit par un portage par l'ADEME sur une enveloppe budgétaire globale d'à peu près 1 milliard d'euros pour accompagner le développement industriel en France autour de 3 principaux piliers que sont le photovoltaïque, les réseaux énergétiques et l'éolien offshore flottant. Donc on a des programmes spécifiques sur l'éolien offshore flottant, du coup qui se déclinent par du financement de projets industriels, de projets de recherche, mais également par l'accompagnement de l'adaptation des infrastructures portuaires pour accueillir ces nouvelles activités industrielles, notamment les flotteurs dont on a parlé tout à l'heure, mais aussi des assemblages, des lignes d'ancrage, bref, l'ensemble des éléments industriels de la chaîne de valeur de l'éolien offshore flottant pourront être accompagnés dans le cadre de ce dispositif.
Cet AMI sera suivi plus tard dans l'année par un appel à projet. Est-ce que vous pourriez nous en dire plus ?
Oui, alors du coup, on a procédé en 2 étapes. On a d'abord un appel à manifestation d'intérêt qui vise à accompagner des études de faisabilité qui permettent du coup d'identifier quels sont les investissements nécessaires pour accueillir ces nouvelles activités industrielles dans les ports français. Les contractualisations sont en cours. L'ensemble des projets seront contractualisés d'ici début septembre. Et un appel à projet qui visera, lui, plutôt à accompagner les infrastructures, donc les travaux en dur. Cet appel à projet sera lancé à la rentrée 2023. On ne connaît pas encore exactement les échéances et les dates à la fois du lancement et des clôtures, mais l'idée est de permettre au port de déposer en bonne et due forme des dossiers de demande d'aide à l'investissement qui, du coup, seront étudiés par l'ADEME pour l'octroi de financement permettant d'adapter les activités portuaires à l'accueil de ces nouvelles activités.
Ces travaux pourraient avoir lieu à quel moment après ?
Alors, du coup, c'est difficile de vous répondre aujourd'hui. Comme on commence à contractualiser sur des projets d'études, d'études de faisabilité, on n'a pas de photos très claires du calendrier et des cadencements de réalisation des travaux. Alors, il y a quand même beaucoup d'annonces qui ont été faites récemment, notamment des objectifs et des trajectoires de développement de l'éolien offshore flottant en France, avec des annonces pas plus tard qu'hier de passer à 18 gigawatts de puissance installée en France à 2035. Et du coup, les 10 gigawatts supplémentaires de la trajectoire vont nécessiter une accélération de l'implantation d'acteurs industriels sur le territoire et donc une accélération aussi des ports que l'on soutient pour la mise en place du coup des éléments nécessaires à l'accueil de ces activités.
Quand on parle éolien, la concertation, l'adhésion de la population locale est un facteur important. Il y a un autre projet auquel vous êtes pas attentif à cet aspect-là, si vous...
Oui, tout à fait. Alors, du coup, l'ADEME est opérateur du programme France 2030 dont je viens de vous parler, mais du coup, l'ADEME est également du coup opérateur de l'État sur les sujets de transition énergétique dans leur globalité et aussi pour accompagner le développement des énergies renouvelables en France Et du coup, nous ne nous mêlons pas que de sujets techniques et que de sujets d'infrastructure. On regarde aussi attentivement l'ensemble des impacts que peuvent avoir le développement des énergies renouvelables sur les territoires. Alors, les impacts environnementaux sont étudiés, les impacts environnementaux sont étudiés traditionnellement. Et il y a un programme, un observatoire sur l'éolien offshore qui porte des programmes de recherche sur les impacts environnementaux. Les sujets que nous souhaitons porter, ils sont sur les autres impacts, sur les impacts socio-éco de l'éolien offshore. Il y a un certain nombre de débats qui vont se dérouler à partir de 2023 dans le cadre de la planification dans les zonages du développement de l'éolien offshore en France. Et du coup, on a souhaité anticiper ces débats par la construction d'un programme de recherche qui va travailler sur l'évaluation des impacts socio-éco de l'éolien offshore. Alors, on a 6 sites aujourd'hui qui seront investigués. Il y en a 3 du coup dans la Manche. Il y a Courseulles, Fécamp, Saint-Brieuc. Il y en a 2 sur la façade atlantique avec Groix-Belle-Île et Saint-Nazaire. Et il y en a aussi en Méditerranée à Leucate, sur lequel on va faire un état des lieux sur l'activité économique des territoires, l'activité de la pêche sur les territoires, mais aussi sur la perception que peuvent avoir les riverains des futurs parcs sur l'éolien. Et on va monter après, pendant 4 ans, des bilans tous les ans, des bilans sectoriels sur les sujets d'emploi, sur les sujets d'impact sur l'immobilier, d'impact sur le tourisme, d'impact sur la pêche, de l'arrivée de ces nouvelles activités, pour alimenter les débats et aussi apporter des réponses objectives à l'ensemble des questions qui pourront être posées par les riverains et les citoyens qui seront du coup riverains des futurs parcs.
Ça pourrait aider à l'avenir de dépasser certains obstacles pour vous tous.
Oui, alors l'idée, c'est pas de dépasser les obstacles. Pour le moment, c'est de les clarifier, c'est de quantifier les obstacles, c'est de bien les comprendre, bien les mesurer. Et d'évaluer si oui ou non il y a des impacts qui peuvent être d'ailleurs dans les deux sens. Il peut y avoir des impacts positifs sur les activités économiques, sur les créations d'emplois, parfois même sur les activités touristiques sur les territoires. Donc l'idée, c'est pas d'évaluer uniquement les impacts sous l'aune des impacts négatifs, il y aura aussi des impacts forts et positifs sur les territoires, sur l'attractivité économique aussi de ces territoires. Donc c'est pas forcément en réaction à des impacts négatifs, c'est bien pour apporter un regard objectif et scientifique sur la réalité de ces impacts pour alimenter le débat.
Merci beaucoup. Buhot, you are Director of Strategy at TechnipFMC. TechnipFMC has projects in various markets, France, the UK and Portugal. In a nutshell, talk us through.
Sure, yeah. To start off, thanks a lot for welcoming us. It's a pleasure to be here and to share the panel.
Could you hold the microphone
closer?
closer?
Sorry, is that better? Yeah. We posted a quick video. Do you think we can launch it?
I think we have a video. Do we have the video?
You don't mind?
No?
And yes, absolutely, Lisa. So going back to your question, so we are involved in a number of projects, so different level of maturity. So that's really ranging from pre-auction up to pre-feed and hopefully soon feed as well, with a number of developers. And so you mentioned UK, Scotland, absolutely. We are also working further to what you said in Norway, South Korea, France, to name a few.
We're now seeing your video and the cable.
It just talks more about our offering and our positioning when it comes to dynamic power cable, but we can discuss over the video. It's no problem.
Yeah, as you're saying, you've got lots of experience with offshore cable projects. Do you think this experience in other markets and sectors is transferable to the floating offshore wind energy sector?
So absolutely. When you look at it, there's lots of common similarities between what we've been doing historically and these new markets. So, TechnipFMC, we've been developing the most complex offshore energy infrastructure for decades in the world, and we can see that a lot of that can be transposed. Notably, as part of our track record, we have installed a lot of dynamic systems, and more relevant to floating offshore renewable power cable attached to FPSOs. So with today 0 failures. So today it's clear for us that we can leverage on all of our existing assets, so our people, our vessels, manufacturing plants, and our offshore EPCI capabilities, to deliver really to the scale, the robustness, and the level of magnitude that floating offshore wind requires now. And actually, we have demonstrated that already because we have participated to offshore campaigns in 2 floating offshore wind projects for Equinor. So in 2009 for iWind demo, and then in 2017 for iWind Scotland pilot.
And from your perspective, what are the main hurdles for you? Because this is obviously the main theme of this panel, the bottlenecks.
Sure. So, and I think it was covered very well by Sonia and Antoine before. So if I take a developer standpoint, very complex equation, but I say that we can summarize that the projects need to reach sufficient economical and risk levels to go through FID, basically, if we summarize. And for that, because they need the proper NPVs, net present values, for their project to really credibly engage billions of euros of capex and years-long contract in very complex environment. And to do that, I think they need basically a combination of 3 things. One, Antoine mentioned it very clearly, is the top line. So basically, revenue-wise needs to make sense in the sense of, right now we are looking at CFDs. So this level of CFDs, they need to be adequately commensurate with the effort of the developer. Later on, when the industry has been proven, like fixed bottom, and we know what LCOE targets can be reached, then maybe they can do a bit of hybridization of their business model with both CFDs and a bit of PPAs and spot market, etc. Then, of course, they need a workable timeline, because every year that you will shave off between your pre-auction work and your first electron is going to dramatically improve your NPV, and today is taking way too long. So from that, they need support both from the regulators, the OEMs, the grid, the state, etc. And certainly they need a fully integrated delivery schedule to deliver the job. And then the foundation that everyone needs is the technology and the supply chain readiness, of course, because at the end of the day, the true value will be materialized when the projects are delivered to scale, to budget, and to quality, to bring the long-term value to everyone.
And do you think that thing everybody has understood, or is there go also for authorities?
This is where it's super exciting to be here, and to discuss, because this is a place that brings everyone together. And from our standpoint, the solution. So our standpoint is more that of the offshore and water column experts. So water column is everything underneath the surface. And from our standpoint, we need to do 3 things all together. First of all, is design jointly, because today I think for understandable reason, developers have spent a good amount of years working on the floaters and on the turbine, the integration of that. But now I think that, and we start to see it more and more, there needs to be a recenter of focus to the offshore operations and to the water column. Why? Because there's lots of risk and lots of opportunities there, and the trade-offs will need to happen at some point. So we need to work together on that, because there is material impact in the procurement and in the installation of these systems, and that needs to happen now. Then there is really a contract early. So even pre-FID contingent on certain conditions being met, but certainly one of the questions is about debottlenecking. If sufficient visibility is given to players like ourselves and the supply chain in terms of potential orders, then we can invest in time to be ready to deliver, and then we will contribute to debottlenecking whilst also being able to cover a bit of the inflation risk. And the third one is we need to de-risk collaboratively, all of us, because at the gigawatt scale and 15 megawatt turbine scale, this has simply never been done. And so everyone needs to work together, the developers, the authorities, the OEMs, and the contractor, to basically make sure that the projects are bankable, that they are insurable, and more importantly, that the risk level are well balanced and distributed amongst the players. Because we believe that there's been a lot of value destruction and missed opportunity in the fixed bottom because of the way technical packages and risk have been distributed, and that absolutely cannot happen in floating offshore wind in our perception, because all of the system is completely intertwined from the rotor, the nacelle to the seabed, and so we all need to work together to make it happen.
Thank you very much, Benjamin Buhot.
Thanks.
Thank you. Let me bring you in, like Paya. You have a microphone? Yes. Okay. You work for Principal Power. You're based in Aix-en-Provence and project manager at 30 megawatt French floating offshore wind development, éolienne flottante du Golfe de Lion. Could you just very briefly tell us the latest about that project?
Hi, good morning, or good afternoon, actually. Thank you for having us
Yeah, thank
here.
you.
So Principal Power is currently supporting various clients in 3 projects in Europe using the largest commercially available turbines. The first project is a Windfloat Atlantic project in Portugal, 25 megawatts. It achieved power in 2019. The second project is a Lynggard project, 50 megawatts, located in Scotland. It achieved power in September 21. For those two projects, we deliver as well O&M services, and we come back to that maybe a bit later on. The third project is the EFGL project, 30 megawatts, located in Mediterranean Sea. This project is going to be deployed using 10 megawatt turbine, which is the largest turbine at the moment commercially available. And this project as well will be using the 3rd generation Windfloat concept, which has been developed using our experience from the 2 previous projects and with a focus on industrialization and modular approach. We've got as well other projects in the pipeline. We've got more than 5 gigawatts of pipeline. Of project in the pipeline, at early stages and basically everywhere in the world with different developers.
And what kind of, given that you've got a wide range of projects in the pipeline, what kind of hurdles have you been encountering?
Yeah, so indeed with this wide range of projects, we've seen many challenges. And today I would like to discuss the 3 main types of hurdles that we can bring today in the context of a large-scale development. The first type of hurdle is a project timeline. We have seen, working with our clients, with our partners, and with other suppliers, that the project timeline proposed or imposed by the governments at the bidding stage is hardly achievable. One of the main showstoppers for meeting the timeline is actually the lack of readiness of the infrastructure, of the public infrastructure, and notably the ports and harbors and the grid connection. We have an example on one project where the harbor were not ready to take our floaters. We had to go even to another country. And for us, we really see that as probably number 1 hurdle, right? The second type of hurdle, which is connected as well to the timeline, is related to project interfaces, a project design basis. What we observe on the project is that those timelines that we just discussed tend to extend for the reasons we just discussed. But at the same time, in parallel, the wind turbine suppliers are racing to propose the biggest turbine in a shorter time frame. So we are facing 2 time frames, like 2 paces. And it is actually not realistic to work in that way. On one project, we had the wind turbine model that changed a few times along the way. So that creates changes in the design basis, in the design inputs, in the interfaces, but as well, it creates insecurity in the project schedule, and it creates more difficulties in the execution. So this is clearly not healthy, and we have to stop this double pace, if you want. And if I may, I would like just to quote Vestas CTO on that matter that recently communicated. He said, "Racing to develop the newest turbine model is not the way to a swift deployment of offshore wind by 2030. So there's awareness already. There's something wrong in the timeline, big timeline on one side, and short timeline on the other side. This big race. The third type of hurdle that we've seen is as being the first to develop those projects. Indeed, we have seen many difficulties, many challenges that is going with this the floating wind industry, and especially the Lynggard project. We delivered it during the COVID pandemic under conditions extremely difficult, with restrictions and rules that were changing every day, and we had to adapt our execution strategy almost every day, to adapt our fabrication process, to adapt our logistics.
And when you look at all these hurdles, is there any easy solution to that? Should people just talk more to each other? Or?
Yes, we should talk more to each other, obviously, and we talked about the supply chain. There are many solutions. There are many solutions around, and Principal Power, particularly with our experience, we can bring many solutions. But I would like to point out to the solutions that relates to the hurdle, right? So obviously, the first solution would be to have, from the governments, from the regulators, a predictable and achievable timeline, and not only in terms of legislation or clean energy target, but as well in terms of infrastructure development. We need to have visibility, with a supplier of the technology, we need to have visibility on those infrastructures. The second solution that we are bringing, at least at our level, the Principal Power, the second solution is we provide to developers a fully optimized, a design that has been fully optimized and fully proven with some wind turbine technologies. Working with wind turbine technologies, we tried different interfaces, we developed different interfaces, and we fine-tuned those interfaces to make our design as robust as possible. But what makes our technology more specific, and we bring a solution as well in the overall picture, is that we provide O&M services. That's what I mentioned earlier. And thanks to the O&M services, we bring experience and lessons from those operations on site, and we re-inject that into our design process in order to provide a design that is as optimized as possible for the entire design life of the project. And finally, again, as a solution, in more in terms of project delivery and project execution, we provide a floater that is designed for project, but yet with the standardized and product approach and modular approach. So at least developers and clients can take our floater and adapt it to different contracting strategy that they have in mind. We bring as well engineering teams and project teams that have gone through the whole life of the project, and this is as well something quite unique in this market, in this industry, and that we see that as a plus, obviously. And those teams have a lot of solutions in mind, and that we can bring to the developers.
Well, thank you very much,
Thank you.
Paya. Solutions, a technical solution. Oh, you have to leave. Thank you very much. Bye-bye. A technical solution is provided by your company. Kent Vinkel, you're CEO of Norway-based WindSpider. Tell us, what exactly do you do?
Yeah, first of all, I would say thank you very much for being here. WindSpider is a Norwegian-based... okay, we're starting with the animation. I wasn't ready for that yet, but we can take that first. Here you actually see the WindSpider in operation, where we are doing MCR and floating. We have prepared the floater for the MCR deck, and then we are using a retrofitted shuttle tanker to move the components from the vessel to the floater. Obviously the critical lifts here are the ones that are being done from the vessel to the floater, and obviously the weather window and the mobility depends on the size of the vessel here. And then it's just a question of building up adding the climbing sections, and then we are ready to do a blade exchange here in this case. And we have the blade tool that we are using here have very good control of the blade. We are actually able to do lifts and exchange in more than 18 meters per second for this kind of operation, which is quite unique in doing this. This also shows installation. In this case here, we're using multi-wheel trailers and a bridge links to handle the components. The dolly tool here is supporting the lifts, both of the tower sections and the nacelle, which obviously gives us very good operability when doing the lifts. And then you see the climbing trolley is moved up and down, and the whole structure is moved up and down by winches. The system is fully redundant, and obviously no single failure will prevent us from operating. The one thing which is obviously unique here is that the entire structure is built around on the floater, which means that there is hardly any relative motion between the floater and the crane lifts, which obviously is very good and gives us very good stability and weather windows. I guess one thing which is obviously a big difference here is that we don't need a big ring crane to do this installation here, and obviously the key sites that are required to handle these big ring cranes, which also takes 2 to 3 months to install, is very expensive. So we think we are able to provide a very good solution both for MCR and actually for all of it. But I will reword a little bit and just start telling you about the company. As you saw here, we are a company that's developed a new technology. We have a slogan that is we call lifting wind to new heights, and that's simply because we are able to lift as high and heavy as the future turbine will require. But also we feel that we are able to lift the industry higher by reducing the cost, but also solving many of the technical challenges and bottlenecks that are in the industry. We are able to offer solutions which can operate in all the different market segments, both onshore and offshore, bottom fixed and floating, and doing installation and major component replacement. One special thing compared to other solutions, that WindSpider doesn't require any changes to the turbine or the tower itself, and that's very important obviously when you talk to the different wind turbine OEMs. And another thing which is obviously very important here is the big topic about MCR and floating wind, where the current solution, and you have been involved in that, where you disconnect the entire floater, the cable and mooring system, and tow the entire structure to the inshore to do the maintenance. That's obviously very time consuming and cost a lot of time. And I guess there's a common agreement between the developers in the industry that this is not a sustainable solution going forward. WindSpider is actually able to do MCR as you saw on site. We can do this operation within 2 days, offering savings beyond 50%. So obviously improving the operability of the wind turbine, but also positive impact on the levelized cost of energy and the entire feasibility of the project. So yeah, and then we should have my animation, but that came first, no problem.
Well, your company, if I understand that right, was founded in 2020. Where are you at now?
Well, since we are from 2020, but we started to approach the market in 2020, and we have actually received very good feedback from the different players, the big developers, wind turbine OEMs, and other stakeholders within the industry. So now we have reached the stage where we are ready to produce the first full-scale WindSpider along with the other key players. That means that we will have a fully tested WindSpider by the middle of 2025 and ready for the market. In addition to this development process, we are also conducting different studies for developers and OEMs and floater designers, typically to assess the compatibility on the floater, to see how it works with the WindSpider, because obviously we are adding some weights and there's some things, interfaces that has to be looked at. But so far we have evaluated 7 different floaters with very good results. And on top of that, WindSpider also hold some patents, and also we have patents application in the pipeline. So we are always continuously looking for developing our solution and technology.
Do you think, from your perspective, we were talking earlier about obstacles and hurdles in the market. From your perspective as a young company that's providing that solution, what are the main hurdles for you in the floating offshore wind energy market?
Well, I guess there's some hurdles, but I think that it's important that people are willing to look at new technologies, and also predictability is very important in respect of that we can actually see there is a long-term market, and then we are able to do the necessary investments that is required. But as I said, the WindSpider solution, I think we are unique in a way that we are able to cover and work in many different areas. As the turbines are getting bigger and bigger in the industry, both onshore and offshore, we have a system that is scalable and is able to handle these sizes as well. And another thing which is also a big issue is, as I said, the ports and the upgrades of the ports. Today, the plan is to install the wind turbines, floating wind turbines, using one of the biggest, world biggest cranes in the world, which obviously puts a lot of pressure on the quayside. And the quayside also has obviously able to cope with that. You have to have a certain draft, etc., to be able to handle that. With WindSpider, we would actually be able to do the installation inshore in sheltered water from a barge or a vessel. Another thing I would also like to highlight is the fact that these wind turbine installation vessels are obviously getting larger and larger. They are more costly and limited in numbers. So obviously limited in numbers is a big issue here. Especially in the US, you have the Jones Act, where which actually basically say that you have to have a US built vessel when you are traveling goods from one port to another. In US, they have to have 5 or 6 wind turbine installation vessels to reach the goals in 2030. Now they have 2 under construction. WindSpider will be able to provide and overcome this by using US-built vessels and also barges and doing the installation. So I think to conclude, we believe that WindSpider is able to solve a lot of the bottlenecks and the hurdles that is coming forward.
Great. Well, thank you very much. Thank you, Ken Vinkel, Eric Paya, and Benjamin Buhot for taking part in this panel. Thank you for listening.